Good morning. Science Lesson 6. It's time to do a review of what you've learned so far. So I've got some slides coming up and I have questions attached to each of those slides. And so the worksheet that you need looks like this. So if you get that worksheet ready, then you'll be able to answer each question. So some of the questions directly relate to the information on the slide, but others are about our learning that we've done in science so far. So I prompt you to pause the video to answer the question, and then of course you can restart it to get your answer and see if you're correct and how your learning's progressing. You can write down your answer on that worksheet, and if you don't have that worksheet, just use a sheet of paper. Are you ready to see how your learning has gone? Let's go. So here's the first slide, titled Electricity All Around Us. It's hard to imagine a world without electricity. Most of the luxuries and conveniences we enjoy in our modern lives rely on a steady supply of electricity. But what is electricity? Where does it come from? And will we have it forever? Well, let's investigate. So, my first question relates to that picture that we just looked at. And I want you to find at least 10 things in this image that you think contain electrical circuits. So, in a moment, pause and see how many you can identify, and then I'll come back with the answer. All right, here we go. These are the things that I found in there. You've got an exhaust fan above the stove. It has an electrical circuit. The hairdryer, of course, the refrigerator and freezer, so whether you separated those, I don't know. There's an electric jug. Now, you might have included the whole stove, but I have broken up the stove into the stove top and the oven. But of course, in each of these parts, there's stove lights, and there's a whole lot of different parts which would all run on different electrical circuits. There's a microwave, a telephone, an electric iron. Tucked in here is the end of a hair straightener. This is either a fan or a heater. And of course, the dishwasher. They're the ones I found. I actually found 12. I wonder if you found all of those or whether I've missed something. I don't know. All right, let's move on to question 2. So, going subatomic. Remember the prefix sub means under or within. To understand electricity, we have to understand atoms. Atoms are the building blocks of all matter, including you and me. Atoms are made up of 3 subatomic particles: protons, neutrons, and electrons. Take a note of the diagram because the next question you'll need to understand it. So question 2, which particle within an atom has a negative charge? So pause and have a go. How did you go? Did you say electrons? They have the negative charge. All right, let's move on to the next slide. What is electricity? Electricity is the flow of electrons. This occurs when energy such as light, heat, or movement causes electrons to move from one atom to another. If you want to have a look at that diagram in more detail, you can pause the video to do just that, but I'm going to keep going on to our question. So question 3, essentially, what is electricity? Remember, base your answer on that slide, pause, and have a go. All right, let's see what you said. Essentially, electricity is the flow of electrons. How did you go? Let's move on. Okay, I'm back because I just had to answer a phone call. Circuits. Electrons will only flow within a circuit. An electrical circuit is a closed path or loop in which electricity flows. Now, I guess if we think about the definition of a circuit starts at a particular point, goes around a pathway, and comes back to that starting point. That's what makes it an actual circuit rather than just a pathway. So a simple circuit consists of components connected by wire. And our diagram here shows the wire in blue. If there are any gaps in the circuit, no electricity will flow. All right, let's have a look at the question connected to this. What happens if there is a gap in a circuit? I think you should know that one. So pause and have a go. Okay, of course, electricity will not flow if there is a gap in a circuit. Right, our next slide talks about circuit diagrams. A circuit or circuits are usually explained using circuit diagrams, and a circuit diagram illustrates the components in a circuit using symbols. As you can see, these are in the shape of a rectangle. This bottom one is the circuit diagram, whereas the top one's more of a picture. So circuits can include a power source, such as a battery. It contains wire, it can contain a switch, and a load, such as a light bulb. And actually, there's no switch in this particular one, but it can contain that. So reading and writing circuit diagrams is an essential part of the work for people who do work with electricity. Let's have a look at the question. It's a two-part question. What shape is a circuit diagram? And the second one, what's the circuit diagram symbol for a power source or a cell? All right, pause and have a go. I hope you said it's usually a rectangle or a square for the shape. And this is a symbol. It's got the longer line and the shorter vertical line. Sometimes when you see this part here, it can be drawn a little bit thicker than this line here. All right, how did you go there? Let's look at the next one. Feeling the flow is the name of this slide. Electricity flows through some materials very easily, but cannot flow through others at all. The ability for electrons to flow through a substance depends on the properties of their atoms. Materials can be classified according to how much electricity is able to flow through them. Let's have a look at the question. True or false? Electricity is able to flow easily through all materials. Pause and have a go. And of course, that is false. Electricity will not pass through some materials at all, luckily for us. All right. The next two slides talk about the different properties of materials and why it will pass through them. So conductors is the first one. So substances that allow electricity to flow through them are called conductors. And examples include metals such as copper and aluminium. These materials have many free electrons that can pass on an electric charge. The human body is also a conductor, which means we have to be careful around electricity. You can see up in the picture here, there's the copper wires encased in the plastic, which makes it safe to use or safe to handle. All right, let's have a look at the question. Two parts again. Metals allow electricity to flow easily through them. What term can we use or can be used to describe this property? So materials that electricity will pass through easily. And then the second part, is the human body a conductor of electricity? All right, pause and answer this question now. All right, how did you go? Of course, the answer to the first part is conductors. That's the name for, or the term for, materials through which electricity will easily flow. And is the human body a conductor? Yes, indeed it is. It can act as a conductor, and therefore it's extra important that we're careful when handling electricity. Moving on. Insulators. Insulators are substances that don't allow electricity to flow through them, and it says these are called insulators. Rubber, glass and plastic are examples of insulators. These materials do not have free electrons to pass on the charge. So it might pay to pay a little bit more attention to that diagram so that it improves your understanding. Electrical cords and switches are covered in plastic to stop electricity entering our conductive bodies. All right, what's the question for this slide? Two parts again. Can you name two types or two examples of insulators? And then can you tell me a device somewhere from around your home and what the type of insulation is on that one? We actually did that activity in one of our lessons earlier on. So pause now to answer this. All right, let's go and have a look. Here are some of the common ones. Hopefully you had two of those ones written down. Glass, plastic, rubber are the main ones, but we can also have wood, believe it or not, air, and porcelain. Porcelain is a form of glass, usually that white glass. Sometimes dinner plates are made of porcelain. All right, so name an insulator. I've got some examples here, such as a remote control, which is insulated by plastic, television sets, tools. I'm certain that you found plenty of things there, but of course the most common ones are plastics and or rubber. Right, where does electricity come from? Electricity exists naturally all around us and even inside of us. Electricity is a secondary form of energy. This means that another form of energy has to be transformed into electricity. And there are several methods for generating the electricity that we use every day. And next week's lessons, we'll start looking at these forms of energy, and so we'll start building up our understanding around there. All right, let's look at the question. What is meant by electricity is a secondary form of energy? Now that's a bit harder. So I hope you took note of what we said there and developed your understanding. Pause the video and have a go. Okay, let's see what you wrote and compare it to the answer I have. Electricity is only produced when another form of energy is transformed or changed into electricity. And that's what makes it secondary. So you've got a primary form of energy or a first form, and when it's changed into electricity, it's the second stage. So it's a secondary form of energy. All right, we will definitely be improving our understanding of that as we learn about all the different forms of energy that we use in real life. And not only us, but all around the world. Transforming energy. Scientists in the early 1800s began discovering the link between magnetism and electricity. They found that if a magnet was spun inside a coil of wire, of copper wire in particular, an electric charge resulted. Therefore, kinetic or mechanical energy, or movement energy as we sometimes call it, in the form of spinning, is transformed into, I'll just wait for that bell. All right. Happens in real life too for us in the class, so nothing we're not used to. Therefore, the kinetic or mechanical energy or movement energy, as I said, in the form of spinning is transformed into electrical energy. And this is the principle applied in power plants. There are 4 different people there who are all to do with electricity. Okay, here's the next question. True or false? Kinetic energy or movement energy can be transformed into electrical energy. All right, pause the video now and have a go at that one. All right, we're back. Let's have a look at that one. Just gone into lunchtime here, so a bit of noise is created. All right, that is true. In fact, the spinning in turbines feature in many forms of electricity production. And again, I'll say we will learn all about that in the coming lessons. All right, done today, guys. How did you go? I hope that was a good revision for your learning. I hope you're feeling confident with your level of knowledge about those elements of our science. All right. Thanks, guys. Catch you next time. Bye now.